Okay, so we've got a real life problem here. We've got a right angle triangle with horizontal eye level is 70 centimeters in length, and the distance from the eye level to the middle of the monitor is 80 centimeters, and it basically creates this angle X. So we want to figure out what is this angle X. So hopefully you should be able to draw your own triangle, and now we should be able to label it with our labels. So across on the right angle, that's going to be my hypotenuse, isn't it? Now look carefully at this. Stand on your angle, go across the triangle. That is going to be your opposite side. There was, I think to be fair, the person isn't in this call, but there was one of you who was getting mixed up between the opposite and the adjacent side. So just make sure you have that correct before you move on. So across from the angle, that's the opposite side, and adjacent, that word adjacent means next to. That's what adjacent means, okay? So the adjacent side is always going to be next to the angle, and it's not the hypotenuse. Okay, so now we've sketched it, we've labelled it, we can use our SOHCAHTOA to figure out which of the trig functions I'm going to be using. So I've got the hypotenuse, can tick the hypotenuse, and I've got the adjacent. Therefore, CAH is the one that I have both of them, so I'm using the cosine ratio here. So it is the cosine of the angle X equals the adjacent side A over the hypotenuse side. Okay, so the cosine of the angle X is equal to the adjacent side is 70, make sure you get them the right way around, over the hypotenuse is 80. Now, because we're trying to find the angle here, to do that, we need to use the inverse function. So it's, to find angle X, it is the inverse of cosine of that fraction, 70 over 80. So what we need to do now, please, is get a scientific calculator, inverse cosine of 70 over 80. Okay, can you do that now? Making sure that the angle you're working with is in degrees, not in radians. Make sure if you're using the scientific calculator on the computer, it's ticked. You've got DEG selected and not RAD. And in the comments, can you type in your answer, please? Okay, thank you, Sam. Anyone else get an answer? Yeah, so I'm guessing you guys have already rounded it, which is absolutely correct to do. Yeah, okay, so it is 28.95. So well done, 955, etc, etc. So if we're going to our standard rounding to one decimal place, yeah, we'd have to round that 9 up, which means it's going to go to 29.0. You're absolutely right. Degrees. Okay, so at the end though, this question, because it's assessment level, we need to actually answer that question. So well done all you for getting that correct number. Now we need to say, right, does the viewing angle meet regulations? Well, the regulations were that it needs to be between 15 and 50. 29 obviously is between 15 and 50, so we need to finish off with a wee statement. So I'm just going to write it above here. So yes, the viewing angle meets regulations. And those of you that are, hoping to progress on to National 5, you need to get used to writing some of these statements to finish off questions, because that's a big part of a lot of the questions in National 5. Yes, the viewing angle meets the requirements, and it's very important that we use the correct language. Always refer back to whatever the question is talking about. The viewing angle meets the requirements as, and we need to say that as 29 degrees is in between 15 and 50. Now I'm going to do it the really mathematical way by using less than and greater than signs. So we can say that 15 degrees is less than 29 degrees, which is less than 50 degrees. Now all that means is that 29 degrees is in between 15 and 50. That's all that means. Okay, but you could have just said as 29 degrees is in between 15 and 50 degrees. That would have been absolutely fine as well. Okay, so that's your little statement. Right, so the question wasn't difficult, it was just a standard find the angle, but then it's just, you know, answering it in the context of the question with a statement. Okay? Right, I'm going to show you one more example, and slightly tougher. Slightly tougher. So let's have a look at it next. Right, so let's have a read through this. So from where Adam stands on the mountain, he sees base camp at an angle of 21 degrees. So imagine if I go to my diagram here, up at the top, there's wee Adam. Okay, so he's up there and he sees base camp, and that angle of depression is called, just basically the angle looking down, is 21 degrees from horizontal to him. So 21 degrees down, and that's the angle to base camp. 3 hours later, he sees the camp, so he's walking down the mountain, he sees the camp at an angle of 15 degrees. And the question is, how far vertically has he descended? So here's what I need to do in this case. I actually need to form two triangles. First of all, using this 21 degree and finding that vertical height total. Then, using this information, forming a smaller triangle and finding just this vertical height. And then the difference between the two of those is going to be the amount of vertical distance that he's dropped. Alright, so this is, to be honest, this is probably slightly beyond that 4 level, but I did want to show you it because I think you guys are capable of it. Okay, so I just wanted to show you this one. So what we're going to have to do is we're going to have to form two triangles of our own. Okay, the first one we're going to form is the big one. So draw these with me. Okay, so I'm going to form a big one here, there, like that. So that's a right angle there. And the angle is important. So I need you to draw a dotted line like I'm doing. Now, we don't have 21 degrees inside that triangle. That's not where that is. We have 21 degrees outside that triangle. So that's very important. Okay, the only other information we know is that that distance down here is 0.4 kilometers. And the distance I'm trying to find is this vertical height, which is the, you know, we're going to find two heights. So I'm going to call this height 1. Okay, so draw me that triangle there. Now, the problem we have at this point is that we don't have any angles inside the triangle. Now, to use trig, I need, you know, one of these angles in the corners, and I need to know at least one of these lines. But thinking back to my angle work, and specifically alternate angles, hopefully you might be able to spot a little Z angle here. There. Remember those angles we did that we thought we'd never actually put them into any use? Well, this corner in here is the same as this corner in here. That's a Z alternate angle because I have two parallel lines, i.e. the horizontal ground and the horizontal eye level, and then I've got a line connecting them. So that means that if this is 21 degrees in here, that this angle down here is also 21 degrees. Okay, so we need to use that rule in order to actually use trig in this question. So now I've got a triangle with angles, and I should be able to find this vertical height. So the hypotenuse would be this side over here, which I'm not going to use. Stand on my angle, go across is going to be the opposite side, and the next to the angle is the adjacent side. Okay, so if I just use my SOHCAHTOA here, right, I'm not interested in the hypotenuse side. Just tell me if you've got any questions, if I'm going too quick, by the way. I know this is a bit of a step up, this question, but hopefully you're okay and you're following along. Don't have the hypotenuse side. I'm looking for the opposite, and I've got the adjacent. So therefore I'm going to be using tan. So it is the tangent of the angle, which is 21 degrees, and that is equal to the opposite side over the adjacent side. So it is the tangent of 21 degrees equal to the opposite side is that h1 that I'm trying to find. The adjacent side is 0.4. Now this is the first type of trig questions we solved. To get this, to solve for this h value here, all I need to do, if you remember, is just multiply both sides by 0.4, which just brings this up to the left, times by tan 21. So it's 0.4 times by the tangent of 21, and that equals my h1. So h1 is going to equal whatever that is if you type it in. So if you can type that in and write it in the comments, please. 0.4 times tan of 21. Now this time we're not going to round as much because we've already got, to 1 decimal place as our answer. So I think we need to round to 2 decimal places in this case. So put that into your calculator and give me it to 2 decimal places, please. Okay, Tiana, that's the right number, but that's to 1 decimal place. So I'll show you the rounding. Oh, hello, Maren, I didn't see you there. Thank you. Yeah, okay. So I'll write it out what I've got. So it's 0.153. Now, up until now, we'd always round to the first decimal place, which would be 0.2, which would be correct. But just because, I'm working with 0.4 already in my answer, I just want to give it another 1 decimal place for more accuracy. So we're going to round this to 2 decimal places, which if we round it to 2 decimal places, it means I round that 5, so that's going to stay as a 5, so it's 0.15 kilometers. Okay, well done. Thank you for all you that got me those answers. Well done. We're only halfway there. That's not answered the question. So we found that overall distance is 0.15 kilometers. Now what I need to find is what is this smaller height using the smaller angle, and then what is the difference in those heights. So we need to pretty much do the exact same all over again using a smaller triangle. So draw your triangle number 2. So it's going to be a bit kind of less steep. And the information we have this time is we're going to do the exact same thing. We've got 15 degrees, which is on the outside of that triangle. We know it's a right angle, and again, we're looking for this angle in the bottom left corner, and we know that distance is the exact same, 0.4 kilometers. So using that exact same Z rule that we used in the first case, which I'll mark it in again, we have Z angles, or a Z angle, boom, boom, boom. So 15 degrees in the top left corner is the same as 15 degrees in this corner. And that allows us now to find H2, which is going to be the smaller vertical height. So we're actually, because the triangles are basically similar, we're going to be labeling it the same, and we're going to be using the same trig function actually. It's just the only difference in the whole this question is actually this angle of 15 degrees. So it's very, very similar. So if you did the first part, you should be able to do the second part, no problem. So this is hypotenuse, opposite the angle, opposite, next to the angle, adjacent. So SOHCAHTOA, we'll just to double, triple check that we know which one to use. We're not using the hypotenuse, we're trying to find the opposite side. We have the adjacent side. So yeah, just confirmed it's definitely tan that we are using again. So it is the tangent of 15 degrees, and that is equal to the opposite side over the adjacent side. So it is the tangent of 15 degrees is equal to h. So opposite side we're calling the second height, h2. Adjacent side is again 0.4. So when we multiply this up again, the only difference is that the angle is changed slightly. So it's 0.4 times the tangent of 15. That's what h2 is. So give me it unrounded, please. So write down to maybe 2 or 3 decimal places and then round it to 2 decimal places after that. Okay? Do that now. Okay, nice. Yeah, getting some answers through and they're correct. So good. Good, good. Everyone else able to get there? Well done, you lot, by the way, for coming on slightly late and getting started quickly. So well done. Yeah, you're all correct. So it's what you should get out of your calculator is 0.107 ... which if I round the second decimal place, which is at 0, because it's got a 7 after it, it becomes 0.11 kilometers. So the overall height of that when he's at the very top is 0.15. The height of from the ground to where he then stopped to look down at base camp is 0.11. So I need to work out what is the difference in those two numbers. Okay, so underneath your working, you're going to write the vertical drop is going to be the bigger one, take away the small one. H1, take away H2. So 0.15, take away 0.11. So some of you I'm sure can do that in your head, no problem. But you've got your calculator there. So take away 0.11 from 0.15. So that's going to be 0.04 kilometers.